Hello, this is a short little video on short-run production functions and using calculus to find the point of negative returns and the point of diminishing marginal returns, right? And so basically what we're going to be doing here is we're going to be looking at a short-run production function, sort of illustrated by this curve. And a short-run production function looks at the relationship between the amount of workers, labor, that you're using in your production function and how much is produced. Now, a short-run production function is based on the idea that everything that you produce is a function of the amount of workers you have and the amount of capital that you use. But keep in mind that the definition of the short run is that capital is fixed, right? So basically we can only affect the amount that we produce by changing the amount of workers we have. Now, when we're thinking about production function, we're ignoring all the other costs and all the other revenue and all the other issues involved in running a business, and we're focusing just on production. Now, the production function has a particular curve to it, right? When you first start adding in workers, you'll notice how the curve accelerates upwards. This is because of the specialization involved. As you put more workers into the workplace, right? Each worker is able to specialize in a job and improve their productivity. And that improvement in productivity, right, as we add workers, goes up to our point of diminishing marginal returns, right? And we have, you see there's an inflection point here. Here, as we add more workers, we're getting more product per worker. Once we go beyond that point, as we keep adding additional workers, the amount of additional product brought in by each worker starts to go down. The reason for this is that we are gradually getting to fulfill all of our capital. All the capital is being utilized to its maximum amount, and that will bring us to our point of maximum product, where if we add additional workers, we'll actually be producing less because the workers will be getting in their way. So what we're going to be doing here is we're going to be finding where's this point of maximum total product and where's this point of diminishing marginal returns. Now we're going to be using mathematics to do it, right? We're going to be using some calculus to figure this out, right? This is a mathematical equation that reflects this curve. And you'll recognize, right, it is a curve. Right? If we want to find the slope in any place, it becomes difficult because the slope is constantly changing. And that's why we have to use some calculus to solve this. Now the calculus that we're going to be using is the power rule. There are a lot of rules in calculus. The power rule is a pretty simple one. If I have an equation that is y, a, x to the n exponent plus b, right, standard equation, to find the derivative of it, to find the slope of it, right, I have to take the first derivative, change in x, change in y. I keep my a, I bring the exponent down, I subtract 1 from the exponent, and the b factor goes away. So basically it's a simple mathematical manipulation that will get us to this. And what we're trying to find here is rate of change at 2 points. We want to find out where adding an additional worker yields no additional product produced, and we want to find the point where adding an additional worker will actually lead to less productivity. That next worker is going to bring in less than the previous worker did. So how we're going to do this is we're going to go first to find our point of maximum total product, right? Maximum total product, right? What we're going to be looking for is where change in our total product over a change in workers, adding an additional worker, will yield 0 additional output. Now, in economics, the term that we use to describe the situation of adding each worker and how that's going to affect the product, that is our marginal product. So whenever we think about the marginal product, right, what we're thinking is mathematically first derivative, or rate of change. Now, to do this, using our equation, using the power rule, right? This is pretty simple. I have a 2 exponent here. So what I'll do is I'll bring it down, and I will have 84L, and then subtract, bring the 3 down, 12L squared. Okay, that's my first manipulation, right? That's the calculus part of it. From this point on, it's pretty much all algebra. What we're interested in here is finding this point where my marginal product, right, equals 0. And this is my equation, 84L minus 12L squared. Well, I can do a little bit of algebraic manipulation here, change my equation here, 0 equals, factor out an L, 84 minus 12L. Now, basically, this will tell me 2 things. First thing, I have 2 possible variants of L, right? This first one, when L equals 0, right, this will all equal 0. But that's obvious. When I have no workers, I'm not producing anything. I'm not really interested in this. What I'm interested in is the middle term. When this equals 0, what is the L that will lead to that being 0? So what I need to do is rewrite this, 84 minus 12L equals 0, which will give me an L of 84 over 12, which will give me a labor of 7. 7 workers, right? When I have 7 workers, my total product will be maxed out, okay? In other words, I should not hire that 8th worker because that will actually cause me to produce less, okay? So that's the first thing I need to do. The second thing I need to do is I want to find this point, right? This inflection point. Well, to do this, I actually have to do what's called taking the second derivative, right? I have this equation here. Let me erase this right now. To find this inflection point, I need to take the second derivative. What I need to do is I need to find where a change in my marginal product over a change in my labor equals 0, right? Where adding that additional worker will, right, lead to no greater productivity. This is my point of maximum productivity. Well, how will I do that? Well, I will do it the same way that I did it before. Power rule. Quite simple. I have my equation. This is L to the 1. So this becomes 84 minus 12, because 2 comes down, gives me a 24L. And I'm looking for where all of this is 0, where my adding an additional worker will yield no additional marginal product. Mathematically, I just use my algebra now. L equals 84 over 24, which will equal 3.5. So what this tells me is that at 3.5, I pass my point of diminishing marginal returns. So what you can see here is that the math is really not so hard, right? The power rule, it's calculus, it sounds big and scary, but it's not. And basically, once I have my equation, I can just do a little bit of manipulation and I can get all the information I need.